Hi, in this video we want to talk about simultaneous equations. Now by the end of this video we'll be able to solve simultaneous equations using the elimination method and the substitution method. So let's start with understanding why we need simultaneous equations. So imagine we have an equation 3x minus 1 equals 5. Now in this equation there's only one unknown, and that unknown is x. And we have only one equation. So let's try solve for x here. We have 3x equals, if we add 1 to both sides, we'll get rid of the 1 here, and that's 5 plus 1. And then 3x is equal to 6. So now if we divide both sides by 3, we have that x is equal to 6 over 3, which is equal to 2. Now what about if we have a situation where we have 5x minus y equals 3. Now in this case, what if we tried solving for x here? We would have that 5x is equal to 3. If we add y to both sides, we have 3 plus y. And if we divide through by 5, we have that x is equal to 3 plus y divided by 5. Now you would notice that on this side of our equation, we did not get a proper solution, a definite solution for x. And that's because on this side of our equation, on the equation on this side, we have two unknowns, x and y. Now in mathematics, when you have two unknowns, it is impossible for you to solve for those two unknowns using just one equation. You need two equations to be able to solve two unknowns. In this case, it was easy because we had only one unknown variable, which is x, and we had only one equation, so that suffices. But when you have two unknowns, such as in this case, x and y, you need at least two equations to be able to solve for x and for y. And if you have three unknowns, you need at least three equations to be able to solve for x, y, and z in that situation. So let's go ahead and solve an example of a set of simultaneous equations. So for our first example, we have that 5x minus y equals 3 and 2x minus y equals minus 3. So like the previous case, we have two unknown variables here, x and y. But unlike the previous case, we actually have two equations, which would make our solutions easy. Now the first thing to do when we have a situation like this is to label our equations 1 and equations 2. That way our equations are easy to identify. And when I say equation 1, you know exactly what I mean. So the first step is to take any of these equations and make either x or y the subject of the formula. I'll just advise that you take the equation which is easiest to resolve into the subject of one formula, and you take the variable which is easiest to find. Now in this case, obviously, it's easiest to make y the subject of the formula. And in both cases, in both equations, they are similar. So let's take equation 1 in this case. So let's make y the subject of the formula in equation 1. So our equation 1 is 5x minus y equals 3. So to make y the subject of the formula here, we subtract 5x from both sides of our equation. So 5x plus 5x cancel out minus 5x here, and we're left with minus y on this side. And on this side, we have 3 minus 5x. But here we have minus y, but we just want only y, not minus y. So the next thing to do is to multiply through by minus 1. Minus y times minus 1 becomes y, because the minus cancels out the minus. And in this case, 3 times minus 1 becomes minus 3. And minus 5x times minus 1 becomes plus 5x. So our y is equal to 5x minus 3. So now we have an expression for our y. So next thing we have to do is to substitute this expression for y in our equation 2 here. So if we have that, our equation 2 then becomes 2x minus, but instead of writing our y, we're going to write this expression. So that's going to be 5x minus 3 equals minus 3. So now we've been able to successfully get rid of our y in equation 2, and then we can solve for our x. So if we expand that bracket, 2x minus times 5x becomes minus 5x, and minus times minus 3 becomes plus 3 equals minus 3. So 2x minus 5x is equal to minus 3x plus 3 equals minus 3. So now we want to leave x on this side alone so we can solve for x. So we can move this 3 over to this side. If we move this 3 over to this side, that becomes minus 3. So minus 3x is equal to minus 3 minus 3, which is equal to minus 6. So if minus 3x is equal to minus 6, then we can divide both sides by minus 3. And minus 3 cancels out minus 3 here to leave us with x. And minus 3 cancels out minus 6 here to give us 2. So x is equal to 2. Now we have that x is equal to 2, but we have our expression for y here. So all we have to do is take our value for x here and put it in for x here so that we can solve for our y. So then our y becomes y equals 5 multiplied by x is 2 minus 3. So 5 times 2 equals 10, and 10 minus 3 equals 7. So y equals 7. So for this set of simultaneous equations, we have that our x is equal to 2 and our y equals 7. So let's move to the next example. For this example, we have that y minus 3x is equal to 3 and x minus 2y equals 4. So we start like we started in the last example, which is to number our equations, equation 1 and equation 2. So the next thing is to take any one of these two equations and make either x or y the surrogate of the formula. So in this case, let's take equation 2 and let's try and make x the surrogate of the formula here. So if we have x minus 2y equals 4. Now to make x the surrogate of the formula here, all we have to do is to add 2y to both sides of our equation. And minus 2y will cancel out plus 2y. So we have that on this side we are left with x, and on this side we have 4 plus 2y. So now we have an expression for our x. So this is our x, 4 plus 2y. So the next step is to take the other equation, in this case equation 1, and to substitute the x here for this expression here. So our equation 1 becomes y minus 3, 4 plus 2y equals 3. So now we've got rid of our x, replaced it with this expression of x with respect to y. So we have only y. Now we can solve for y. So y minus 3 times 4 becomes minus 12. And minus 3 times 2y becomes minus 6y equals 3. So y minus 6y becomes minus 5y minus 12 equals 3. So now if we have our equation, then becomes minus 5y. If we move our minus 12 over to this side, just so that we can leave our y on this side alone, we have equals 3 minus 12 when it moves here becomes plus 12, and this is equal to 15. So if minus 5y is equal to 15, if we divide both sides by minus 5, minus 5 cancels out the minus 5 here, so we have that our y, and 15 divided by minus 5 becomes minus 3. So now we have that y is equal to minus 3. So we have to substitute y into this our x expression to get our x. So then this equation then becomes our x is equal to 4 plus 2. And we know that y is equal to minus 3. So this is minus 3. So x is equal to 4. 2 multiplied by minus 3 equals minus 6. So x is equal to minus 2. So for this particular set of simultaneous equations, we have that our x is equal to minus 2, while our y is equal to minus 3. So we do one last example for solving simultaneous equation using substitution method. For this example, we have that 5x plus 3y equals 12 and 7x plus 2y equals 19. So we start like we've done for previous examples. So we choose one of our equations. Let's choose equation 1 and let's make x the circular formula here. So if we do that, equation 1 is 5x plus 3y equals 12. So if we want to make x the circular formula here, we'll subtract 3y from both sides of our equation. So minus 3y minus 3y. Plus 3y minus 3y cancels out. So on this side, we're left with 5x. And on this side, we have 12 minus 3y. But we still have this 5 here. So to get rid of this 5, we divide both sides by 5. So if we do divided by 5 here. Now, the 5 here cancels out the 5 here. So on this side, we're left with x. And on this side, we have that 12 minus 3y divided by 5. So now we have an expression for our x. So the next step is to take this expression and substitute it into equation 2. So our equation 2 then becomes 7. But instead of x here, we have our expression for x. So that's going to be equal to 12 minus 3y divided by 5 plus 2y equals 19. So now let's expand this bracket. 7 times 12 is equal to 84. 7 times minus 3y equals minus 21y divided by 5 plus 2y equals 19. So to get rid of this denominator here, first let's move 2y to this side of our equation. If we do that, our equation then becomes 84 minus 21y divided by 5 equals 19. 2y goes over to this side to become minus 2y. And then we can cross multiply. So if we do that, we have that 84 minus 21y equals 5 multiplied by 19 minus 2y. And so 84 minus 21y equals 5 times 19 is equal to 95. And 5 times minus 2y equals minus 10y. So now we can collect like terms and solve for y. So if we do that, we'll have minus 21y on this side. And if we bring minus 10y over, that becomes plus 10y equals 95. And if we bring 84 over to this side, it becomes minus 84. So minus 21y plus 10y is equal to minus 11y. And 95 minus 84 equals 11. So if we divide both sides by minus 11, just so that we have our y here alone, minus 11 cancels out minus 11, and we're left with y, and 11 divided by minus 11 is equal to minus 1. So we know that y equals minus 1. So now that we know that y equals minus 1, we come into our expression for x here and substitute for y. That way we can solve for our x. So here x is equal to 12 minus y equals minus 1 divided by 5. So x is equal to 12. 3 times minus 1 is equal to minus 3. Minus 3 times minus is equal to plus 3 divided by 5. So this is the same as 15 over 5 equals 3. So x is equal to 3 and y is equal to minus 1. And that's all about solving simultaneous equation using the substitution method. In the next video, we're going to be looking at solving simultaneous equations using the elimination method.